Today I'm going to show you how to draw one of the iconic buildings in Abu Dhabi, Ferrari World. I chose this building due to symmetrical geometry, various curves on the surface, and personal interest in Ferrari. I'll take you through the modeling strategy first and show you a breakdown step-by-step scripting in Grasshopper. Let's get it started. Since this building is highly symmetrical and circular, we will need to slice the building in pieces. I decided to break it down into 6 sections. First, we need to find the critical bending points and construct each panels individually. Points will be created from the center circle. Each panels will be joined up together, then mirrored to complete the 1/3 of the building module. And we rotate the module 3 times by 120 degrees. Okay, let's try to draw this building in Grasshopper now.
Okay, first of all, we need the background information that we can reference into. So type picture. I've captured this Google Earth image before, so what I'll do, I'll drag and drop this bitmap. All you need to do now is that we have to scale it to the true scale. So type scale, and we know we have this reference, the measurement at the bottom of this image. So type 100 to get it to the right measurement. So let's place somewhere around there, and next we need to create that inner circle of that roof, and the second we're going to do the outer circle. Type circle, and we need to define x and y. Point will be somewhere around roughly there. That goes there, and give somewhere around 50. Yeah, it's about in the center. We'll offset this and give about 45. Probably have to increase it slowly. Give 50, a nice round number, somewhere around there, right? And we'll have to break it down into 6 parts. So the target section that we want to construct is that, the 1/6 of the building, the roof. And then we're going to flip it, rotate it to complete the whole geometry. So the first of all, we'll have to type evaluate curve, and that goes to curve, and we're going to reparameterize so we know that it runs from 0 to 1, and that means to get it 1/6 you will have to divide 1 by 6, so that gives 0.167, and we know the starting point will be 0. No, and that gets to, so let's see where that sits. Okay, so before, so I put in the wrong place, so that goes to parameter. Right, so the starting was there on the right hand side, and that goes to anti-clockwise. Okay, so we know, just bear that in mind how it runs. And what we want to do next is that we want to rotate this, the background image, so that we know the target, section is placed in the right angle. So the sim there, it should go roughly around there, thereabouts. Okay, so that sim runs there and there. Slightly misplaced. I will move that. Okay, that looks about right, because you'll never get 100% accurate because the background itself isn't 100% orthogonal because it's been taken from the space. All right, so I'm going to lock this. So next is that we have to get these points to these critical bending points, So like I explained it before in the principle and the modeling strategy, we will have to construct this in pieces, So the first half of the spindle will be constructed by 2 curves, and then it will get constructed that, the shield part, the second shield part, and the third and the fourth, all consecutively, and then we're going to join them all together, and then to do the further action. So we know that's how it's been, placed in the right place. And now I'm going to unconnect that for now. So what we need is we need a merge tool. So this allows you to get this in the right order. So we're gonna have how many, critical bending points? So 1, 2, 3, 4, 5 bending points. So we know there will be 5 input data. So get it all the way up to D5. And we know the maximum, the number doesn't get changed over or go over 0.6167 because that's 1/6. And to saying the truth, it has to go further down than this, but just for the simplicity, I want to just run it up to the 3 decimal points. Okay, so I'm going to go ahead, edit that. So maximum will be 0.167, type enter, so it doesn't get beyond 0.167, and everything will sit between 0 to 1.67. Okay, so that copied 3 times. So I will place it randomly somewhere in between these two numbers, right? And I'll connect in the right sequence. So that result, if you connect that to parameter, you see that point's been placed along this curve. And we'll do the same. So copy and paste, and that gets connected to offset curve. And we know these two are in a perfect line to get to the critical points. Okay, we'll have to tweak these 3 variables to get it at absolutely perfect bending points. We will do that test later, so play with that later just to make sure that it sits somewhere that is visible. So second, we need to construct the projection lines. Okay, so we know how to do that from the previous tutorial. So I'm going to build a vector from 2 points to get the direction. So we know point A, point B, so that will project that way, project that way, project, so on and so on. So the vector is placed there, and we're going to use line SDL, which requires a starting point, which will be each of these points, right? So we know the starting curves are all there. It doesn't really matter where you start it, but since we got that as a circle, in a circle, we're going to take that as a base circle. So I'm going to break it down with list item. So what we need is we need all of these, the evaluated curve points. So that goes there. We know there are 5 inputs, so there will be 5 outcomes, right? So we'll need to get it all the way up to, 4. So starting from I, which will always be by default 0, 0, 1, 2, 3, 4. So there are 5 numbers, okay? So we'll need that, and we need another, the vector, which runs from 1, 2, 3, 4, 5. So the starting is there, and direction is there, and we need a length. I'll give us somewhere around 300 because it's a quite large building, right? So I'd imagine, okay, that's quite far. Bring it down there, okay? Okay, this isn't perfectly aligned, so let's unlock it and rotate it again. Just get it 100% accurate. We're saying that it will never be 100% accurate. So we try to align it as best as we can. So that's that seam, right, of that building roof sits with that first line that we just defined, okay? So to get the, lock it again, just in case I'm moving about. So to get the endpoints, type endpoint, right? So you get the point, 2 points. So you now got the point there. So we're gonna run the same, the step to get to these additional 4 points, So what I'll do, we don't need a cluster for now because you're not going to get that data to get the cluster actually working. So you need the data, and so cluster it. So you always get the endpoint. Okay. So what I'll do, I'll get this copied. So you need to copy all of these. Okay. So starting point goes there. Repeat that. See that endpoint sits there, and again.
Starting point there to there. Okay, do the same. Fourth point.
Rightio, let's place these roughly about the right place. So that goes there, oh, sits further. So now it's time to play with this a little bit. So we know that it's nearly there. So let's push it up to 300. Let's push up to 400 because I like round number. So that's roughly about there at the end point. Just so third one. So we need to place that to that point. So you see that it's bending, twice. So that's the critical, how to say the critical bending point. So you will have to rotate that. Just, this is the third one. Sorry, it's like a shooting game, isn't it? So let's get it right. Get to the target. Okay, I'll give you that. So the fourth will be there. So I want to get it to that sim, right? So that sim there, that's my aim. So get it there. Okay. So take that further. Okay, that's about right, and I need to bring it all the way down. So that's just there. So I will explain this again. So we'll need that to be half of the spindle to be constructed, and that to be constructed separate, and then that to be constructed separate, and then that second shell to complete that whole section. So we know what we need to use, right? So we'll need to bring these, up to Z coordinate as well, because we're not just going to build this in flat surface. So let's give that an action. So let me just bring this all slowly down so that I will have some space at the top. So what we need is, so we're going to repeatedly use this command. So moving in Z direction. Okay. So the building, I don't imagine that goes beyond 60 meters, probably do, but you have a flexibility going up all the way up to 100. So let's define this first curve, how far that moves, right? So we want to move that somewhere around, so that I'd imagine somewhere around 40. So that gets connected to there, and what we need to do, we would need to substitute that circle. Okay, so we need to substitute that with where we connected there. So that gets to there, that gets to there, and we need to move this second circle. So let's go to perspective view to see, and let's move that, because like I said, it will be repeatedly used. I'm going to cluster this. So this, all we need to do is just copy that across. So this is a way to organize your Grasshopper scripts a bit neater, because otherwise you will end up with so many nodes that sometimes you get really confused with what you're doing. So let's bring it down somewhere around there. So that Ferrari World, this inner circle starts from a lower part, and then that dips up, and then everything slopes down. So that's that. Or alternatively, you can keep it where they go. So that curve goes back there, that goes back there. So probably what we can do is that we just move these points up instead of bringing everything up. All we need is these points moving up. So the second gets slightly higher up. So now let's try to move these points as well before we connect them into curves. So I'll copy these, paste, bring it there. So we know that is the starting point of that. That I'd imagine go up somewhere around. So this is the opening part. So that goes somewhere around, how to say, 19, 20. Okay, second, let's move the second curve. That one is the beginning of the slope. So that I don't imagine that gets any higher than 4 meters. So I'll give 4 meters. And a copy and paste, and that goes down, and that gets up as high as that. So if you imagine, you try to, you have to sculpt this quite carefully. Just there, and then fourth one gets, I'd imagine that gets slowly high up, and now you're entering to the peak of the aperture, so that goes somewhere around 40. What we need to use now is that we need to use curve, there and there. So this time I'm gonna show you there is arc with 3 points. So I'll start with this. So we know 3 points there. So if you connect these 1, 2, 3, you'll get the curve like that. And that applies the same here. So we know 1, 2, 3 points there. So what I'm going to do, I'll bring all the way there. So we know that's the point. That's the point there. So we'll have to disconnect that. So you could just simply copy that too, because he's already got the 5 outputs. So we know if you input that, you will get 5 outputs. So we want to get 3, 4, 5. So 3, which is 2, 3, 4. That construct a curve there. So if you loft these two, you will get that part of the roof. So let's type loft, connect that curve to that curve. So you got that section built. Let's go in 3D. That's quite nice. That's really built. So the second part that we need to do, we need to get the same thing again. So we need to get that built and that section built. So copy that. So we want 1, 2, 3. So we got that built. So now we need to get these two connected, and we build that complete section. So we know that's third and fourth. So build line, type line between 2 points, so starting and end point. So that's the line there. So let's loft it again. So type loft and connect there, and also that arc goes there. So we now got the complete shield, of 1/6 of the Ferrari World. Now we're gonna get that, the spindle, the crab hand, and that to get that, so we need to construct that curve and that curve. So we need a arc with tangent point, so that's that. So starting is that and end is that. So we're going to connect the start and end. I'm going to try to grab the number 4. Sorry, so what we want to do is the list item. Run that between number 0 to 4. Type goes to index, that list gets to the tangent. Okay, so that's good. Right, so that gets connected to their direction. Okay, somewhere around 4. It isn't perfect, but we'll give that, as the outer shape of. And the second that we need to get is we're going to use NURB curve, and that will get a control point from this line there. So I'll do evaluate. Curve goes 0.0021. Parameter connects to there. So if you run it there, it goes slides up. So that has to sit somewhere around there. We're going to create a NURB curve based on these 3 points. So 1, 2, and 3. So that's been constructed there, and if you move it and roughly position it somewhere around there, I'm going to give 2 for the degree. Let's loft it. Let's loft these 2. And curve and curve. Okay, so we'll have to flip this. Flip curve. That. There you go. So we now finished building the first part. So that looks a bit funny. So increase that height so that it gets somewhat quite smoother. That looks about right and good. So what we'll do next is that we'll join this brep. So we'll also have to finish off these two curves to be lofted too. So we know these two curves are, we know that's that curve, that's that point. So let's construct arc 3 points. We know that's there. Next, so arc 1, 2, 3, and then we want to get another arc from here. So I'm going to grab the one in the mid and the last, and if we loft these two, that bottom and the top there, and let's flatten it because data trees on quite the same. So now we've finished constructing the 1/6 of the Ferrari World. That moves there. So we know these parts all needs to be joined up. Connect these two, join brep. Offset the preview. And let's mirror this. And we need to get the plane, which will be that. So we need to construct the plane. So I'm going to type construct plane. So we need to grab the vector data. So when you've got that vector, to grab that all the way. So imagine that. So what we want is that we want to use that axis as a mirror plane. So we need to grab that because we know that is running that way. So that goes to X. Origin will be the center of the circle. And the Y will be Z direction. So that goes there. So you see that? It's plane there, and if you connect that, it's completed the whole part. Right, so again, we're gonna do the join brep again. So join brep of these two, the first one and the second. I'm gonna turn off the preview. So what we need to do now is we need to rotate that 3 times. So we're gonna use rotate. Let's go all the way back to the beginning again to get the original plane. Connect there. Geometry connects there. Sorry, I guess the angle placed in the wrong place. And angle has to change. So we want to run that twice. So I'm going to use a series. Step is 120. And that gets degrees. Right click and make sure that you select degree. Then we want to run that 3 times. Starting from 0, that goes to angle. Turn up the preview. Now we have completed the Ferrari World. So that's it. So I hope you enjoyed it, and we'll see you next time. Thank you for watching.